Hi guys, in my last video I introduced to you a new variant of environment sensor, which is basically in the form of Arduino Uno shell. uh, in that introduction I use or I leverage example from infrared uh, uh, application in Arduino and connect that to the environment sensor. And at that demonstration, part of the demonstration is just to demonstrate infrared receiver functionality, infrared transmission functionality. In one of the example, I send a command to turn on a fan. At that point, uh, we could not find I mean, there is no information that we can get in terms of the fan speed. And I thought that would be useful. I mean, if you have a legacy fan, when you turn it on, it has different setting. You might want to know what are the speed of the fan. So I look around, and it turned out to be there is another example in Arduino. What they did is basically they have library that you could do uh, measurement or like some sort of a uh, I mean, it's basically an RPM meter or tachometer. The way it is being, the way it works is basically it has an infrared transmitter, shining light, shining IR, and then it being reflected, and it being detected on an infrared receiver. So it's using the same component but a little bit different of technique. So when the signal is reflected and come back, it generates a pulse. So we will be measuring the uh, interval between pulses. That will give us a frequency, and then from that frequency we can use the math to calculate the RPM. So this is hopefully going to be a short demo to show you that we could get that information. And then since we are working with infrared, I would once I get the information here and calculate the RPM, I'll be sending that information using another infrared to the infrared receiver on the other side. The way I send that information is just basically like another remote control command with a different value. That value is the RPM value. So instead of doing an action, I would be just displaying that information in the dashboard, in the hubitat dashboard. So let's get started and start the fan. Okay, so let's get this fan running. And let me go ahead and go to the hub. Okay, now it start measuring. I mean, okay, let me focus on that. Okay, so it start displaying RPM. So I'm gonna attempt to change speed on the fan, and hopefully we could see the value of the RPM change. If you can hear the sound, the fan is getting slower, and the RPM should go down. Let me bring it down as much as I can. Okay, so now I'm gonna make the fan faster and see how far we can go. There you go. So the way I'm doing this, I mean, everybody could do it a little bit different because you could program it the way you want it. I'm doing it like every 20 seconds. I take a sample of the speed. So and then at that point, I send that information through the IR. Uh, I mean, that's flexible. I mean, there's a code there. I'll be happy to share them if you like it, but I mean, it's not that hard to do. I mean, but the technique, the idea of using infrared measuring, it's probably could make some of our fan a little bit smarter. So there's a lot of things that you probably can do knowing the speed of your uh, fan. Imagine that you know those information and be able to use that in your roll machine. Probably one thing that related to this is just controlling the fan speed based on the temperature on those older fan. Uh, so that's probably something that obvious to do. But other than that, uh, like maybe based on the speed of the fan, you could I mean obviously fan generate sounds. If you have a stereo system, you could adjust the volume of your stereo system, things like that. But the basic principle on how you could measure it, you could send that information, it's something that I think doable, and a lot of people has done that, and there's a lot of information in YouTube how to do that as well. If this is something that interesting, and if something that you want to know more, and then I'll be happy to I mean dig through about this possibility. But for now, it's just a rough demo, rough prototype.